A survey was conducted 2 years ago asking college students their top motivations for using a credit card. To determine whether this distribution has changed, you randomly select 425 college students and ask each one what the top motivation is for using a credit card. Can you conclude that there has been a change in the claimed or expected distribution? Use alpha equals 0.025, complete parts A through D. The table gives 3 columns. There is a response, and there are 5 different responses: rewards, low rates, cashback, discounts, and other. Old survey percent gives you 27%, 24%, 21%, 8%, and 20%. The new survey frequency F is 111, 98, 108, 47, and 61. Part A is multiple choice. It's to state the null hypothesis and the alternate hypothesis and identify the claim. So we want to define what H sub 0 is, or H naught, and H sub A is. First part says, what is the null hypothesis H naught? There are 3 choices here, but basically when we're looking at this particular question, one of the things that we know is that our null hypothesis is always a statement of equality. So when I look at these 3 statements, what I'm seeing is the distribution of motivations is, so that's a statement of equality. The distribution of motivations is, that's a statement of equality. The distribution of motivations differs from the expected distribution, so that's not a statement of equality. But what we're trying to do when we look at this particular problem, it says, can you conclude that there has been a change? So my null hypothesis is the fact that the distribution of motivations is 27% rewards, 24% low rate, 21% cashback, 8% discounts, and 27% or 20% other, because that is our original survey data. We're trying to find out if there's been a change from that. The next part of this is, what is the alternate hypothesis H sub A? A, the distribution of motivations is 27% rewards, 24% low rate, 21% cashback, 8% discounts, and 20% other. B, the distribution of motivations differs from the claimed or expected distribution. C, the distribution of motivations is the same as the claimed or expected distribution. Remember that since we've already chosen the null hypothesis, which is choice A up here, we cannot choose the exact same thing to be the null hypothesis, so we will discount that. We'll look at part B. It says the distribution of motivations differs from the claimed or expected distribution. Well, that's what we're looking for. We're looking for a statement of non-equality, and we're looking at a statement that says it is different from what we're stating as a null hypothesis. So this would be our choice. And obviously, if we look at choice C, the distributions of motivations is the same. That makes no sense because we're trying to find out if there has been a change. And so finally, in part A, the question is, which hypothesis is the claim? Well, we know what the null hypothesis is, that the original data is the distribution. We know what the null hypothesis is, that the distribution of motivations differs from the claimed or expected distribution, but it goes back to what did we first ask in the question, which was this: can you conclude that there has been a change? That is my claim. That's the the alternate hypothesis. Part B says determine the critical value chi-squared naught, or sub-0, and the rejection region. So first we need to go ahead and determine what our critical value is going to be, and for that we will need to use the chi-square table, which is found in the textbook. This is table 6, and we are looking at an alpha of 0.025, which is going to be this column right here. And we want to go ahead and look for our degrees of freedom, which in this particular case is going to be 4. Since we have 5 categories, we will subtract 1. So our chi-square value is going to be 11.143 from the table. The next part of the question asks or states, choose the correct rejection region below. Since the chi-square test in this case is a right-tailed test, the rejection region is going to be to the right of chi-squared naught. And it will not be equal to, it will simply be greater than. So the calculated test statistic, chi-squared, must be greater than the table value for chi-squared that we have just found. Part C says calculate the test statistic, and we will do that using technology for this particular problem. And for that, we're going to use StatCrunch. The little icon to the right of the table in the problem is a copy icon. If you left click that, this pop-up menu right here will pop up, and we're going to choose the top option, open in StatCrunch, and it will populate StatCrunch with our data, and it will look just like this. And you'll see that all three columns from the table have been copied into StatCrunch. Now remember that we need to have actual number figures for the old survey data, and we do not have that yet, and we are going to convert that. You'll notice right here in this column that it is in percentages. However, when it is copied into StatCrunch, the percentages are gone, but those are still percents. And in order to calculate this, we need to have figures that represent the number of students, not the percentage of students. So we're going to calculate this based upon the students that we have surveyed. And we have surveyed 425 students. So in order to get our expected values, and that's what we need, our expected values, we will take the percentages from this column, convert them into decimals, and multiply by 425 to get values. But we are going to use StatCrunch to do that for us also. So in StatCrunch, you will left click the data button, you will scroll down to compute, and then you will left click expression. We are going to build an expression, so we'll left click build. And so we're going to start with opening a set of parentheses. Then we're going to double click old survey percentage. We are going to divide that by 100 to put it in decimal format. Close the parentheses. I'm sorry, you don't need to reconnect that or redo that because the parentheses are already being closed. There we go. Then we're going to multiply that by 425. And that's what's going to go into our column. So we'll click add column. Sorry about that. We're not going to add column. We're going to click OK. And this is our new expression. And so we'll left click compute. And that's going to give us our new column, which is right here. These are the values that we're looking at for the old survey. Now we can do our chi-square test. So we'll left click stat. We'll scroll down to goodness of fit and left click chi-square test. Now this is important because we're going to use the new survey data as our observed. And our expected is going to be the new column that we just generated, which is old survey percent divided by 100 times 425. And then we will left click compute. And right here is the data that's pertinent to this problem. And we see that the chi-square value is 15.965546. However, this tells me to round it to 3 decimal places, so it will be 15.966. And that's the answer that we'll put right here. And now we need to answer the following question. Decide whether to reject or fail to reject the null hypothesis, then interpret the decision in the context of the original claim. All right, in order to answer part D, we need to compare the calculated test statistic and we need to compare the test statistic that we found in the table. So that means that chi-square, in order for this to be a test, is going to be greater than the table chi-square statistic. So we look at our chi-square, which is 15.966. We're trying to determine if that is greater than what we pulled out of the table, which is 11.143. And we note that in this particular problem that this is definitely bigger than this. So that means that this value falls in the rejection region. And now we can say that we will reject the null hypothesis. At the 2.5% significance level, there is enough evidence to conclude that the distribution of motivations differs from the claimed or expected distribution.